Okay, we'll start with a nice simple binomial expansion. We'll expand x plus y to the power 4. And because the power is quite small, it's easy enough to use Pascal's triangle. So here's Pascal's triangle. And if the power is 4, that means we want the 4th row. Starting from 0, we've got 0, 1, 2, 3, 4. A way to make sure you avoid mistakes here is that there is always one more term in the row that you're looking for than the power. So if the power is 4, you should have 5 terms in the row from Pascal's triangle. 1, 2, 3, 4, 5. So let's get started with the expansion then. We've got x plus y to the power of 4. So first of all, we could put in our binomial coefficients. We've got 1, 4, 6, 4, and 1. And we'll put a plus in between each of these terms. Sometimes when you have a minus sign in here, when you simplify everything, you end up with negatives. But on your first line, you should always have pluses in between the terms. Next, we'll fill in the x parts, which all come from the first term. The first term will be x to the 4. And then for each successive term as we go along, we're going to reduce the power of x by 1. So we'll get x cubed, x squared, x to the power 1, which we just leave as x, and then x to the power of 0, which is 1, so we don't write it in. Then for each term, we're going to add in the powers of y. We start with y to the 0, which is 1, so we don't write anything here. Then we have y to the 1, y squared, y cubed, y to the 4. And then finally, to save writing out an entire line of working out, we'll just rub out these ones that we didn't really need here. So normally we wouldn't write the ones in, I just wanted to do it this time to make the links with Pascal's triangle. So just to recap, first of all, we write down each of the binomial coefficients and we put a plus in between each term. Make sure you leave plenty of space. When you're first doing these, you might want to practice them on a mini whiteboard or some rough paper so you can get a feel for how much space you need in between each term. After that, we put in the powers of x, which will be descending, so x to the 4, x cubed, x squared, x and no x's. And then we do the powers of y, which are increasing, so no y's, y to the 1, y squared, y cubed, and y to the 4. Okay, here's a problem for you to try. I'll leave Pascal's triangle on the left in case you haven't got it written down for yourself. So have a go at expanding x plus y to the 5 and then come back and check your solution against mine. Welcome back, here's my solution then. So if we want x plus y to the power of 5, we want the 6th row with 6 terms, which is this row in Pascal's triangle. So we've got x plus y to the 5 equals, and then the first term will be x to the 5, and the very final term at the end will be y to the 5. The binomial coefficients of these two terms will be 1. And then I'm going to put in my other binomial coefficients. So I've got 5, 10, 10, and 5. And we'll put a plus in front of all of these. Then we'll fill in the rest of the powers of x. We've got x to the 5, x to the 4, x cubed, x squared, and x. Then we'll fill in the powers of y increasing, none in the first term. And we've got y, y squared, y cubed, and y to the 4.